Swayam Prabha. Digital India. Educated India.
Welcome back to lecture number 27, part 1 on the topic cold chain in the subject refrigeration and cold chain management. In the first half of the cold chain management, we have discussed about the storage design requirements, shelf life, how to extend the shelf life of a product, what are all the various models pertaining to food deterioration. We have seen kinetic model, Q10 model, time temperature tolerance, that is triple T models, different models, how these models are used to predict the shelf life of the product. And based on this, we have solved numerical questions also. It is the preservation of products from the time it is taken from the period of harvest until it is consumed by the user in the market. The preservation of the product. Some of the topics in this portion may be a repetition of what we have discussed in the previous lectures. So the preservation of the food products, it could be any product from the farm until it is consumed by the end user. So that is what cold chain refers to. So there are several stages of cold chain. One is the selection of proper seeds and plantation. So this is very, very important. If the proper seed and the plantation is not selected properly, and then obviously the produce or the output of that harvest may not be a good one. Cultivation, usage of proper nutrients, it is very much essential. Proper nutrients. Harvesting when the crop is ready. So here the nutrients refers to the nutrients that are used for during the period of harvesting. Then the cutting and the removal process have to be done carefully without any wastage or without any loss of products at the farm level. Grading as per the size. This is very important. Grading as per the size, appearance and quality. Sometimes the products which are of very good quality, it may be classified as category A. Not class A, class A, class B, class C, class D. Those classifications are based on the moisture content, which we have discussed in the shelf life of the product. This is after the product is produced, grading of the product, whether it is if it is of top quality, maybe it comes like category A products. Next best quality, moderate level quality, it could come in the next 2 or 3 categories, and so on. Packaging of the product. This is very, very important. In the subsequent slides, we'll be discussing about the controlled atmosphere and modified atmosphere. Pre-cooling techniques at the farm. This is farm and the day storages. As I have explained in one of the earlier lecture, if there's a delay in the pre-cooling process by 1 hour, then there is a chance of the shelf life of the particular product would be reduced by close to 1 day or 18 to 24 hours. This is based on the assumption that the ambient condition is around 35 degrees centigrade. Transportation to the main warehousing cold store. The problem is, in some places there may be the cold storage facility which is available only at the main place. It may not be there at the place where the product is produced, or there may not be a transportation facility like a refrigerated truck or refrigerated van to shift the product from one location to another location. Proper storage and stacking. This is in the cold room, storage and stacking at the required temperature, humidity, air velocity and air quality. This is very important. This storage conditions varies from one product to another product. The temperature requirement will be different, the humidity requirement will be different, and it varies from one commodity to another commodity. Control of carbon dioxide, oxygen, ethylene, wherever it is necessary. Modified or controlled atmosphere to extend the shelf life of the product. Transportation to the cold store for the city distribution by refrigerated truck, rail or transport. So when it comes to transportation, it is not only from the farm to the city, even within the city, like from the city to the nearby town or whatever it is, nearby district, all those things. Or within the cities also, there should be a refrigerated transportation facility to be available. Intercity daily distribution within the designated city by smaller refrigerator vans. Smaller refrigerator vans are vans using utility plates for products like ice cream. So when we see the transportation vehicles, I mean, we can say, apart from the nature of the vehicle, we can say vehicles which are meant for long distances, which are meant for medium distances, and which are meant for short distances. That is, vehicles which are used for, like suppose if you want to transport ice cream or butter from within the city from one place to another. So though for those kind of things, the small kind of vehicles, small size vehicles are used. Use of multi-temperature vehicle and ability to carry mixed cargo. So this is multi-temperature vehicle is used for multi commodities, multiple, not multi, maybe yes, multiple commodities whose storage temperatures are different. Display cabinets, open or close freezers, coolers in supermarkets and stores. So if I've just give a brief introduction about the concept of the cold chain and its process. So this is how a typical cold chain looks. So this is picking, this one, then packing or packaging. This is the process of cold chain right from the farm till the product is produced and transported till it is consumed. So picking, packing, then loading, transportation, then comes the pre-cooling stage. Before storage, the pre-cooling process is done. Then it is loaded in the refrigerator vehicle. That is, from the storage it is unloaded. Then it is subsequently loaded in the refrigerated vehicle. Then it goes to the storage and sale, and finally it reaches the end user. So need for cold chain. From the moment the crop is harvested, the nutritional values starts to get diminished, and this increases if there's a delay in if a proper pre-cooling or a storage facility is not available. So the diminishing rate of the nutrients is directly proportional to the delay in having a proper method. The nutrition of the product diminishes from the moment the produce is harvested. As this is like 1 hour time loss in the ambient condition of 35, this I have already explained. between the harvest and pre-cooling, between 1 hour time loss, that is between the harvest and the pre-cooling, can reduce the quality of the food product by about 20 hours. Sometimes it goes up to 24 hours, that is 1 day. So this brings down, situations like this brings down the shelf life of the product, reduces the shelf life of the product. Delay in pre-cooling results in moisture and weight loss. This is very important. Delay in pre-cooling results in moisture. Once there is a moisture is lost, there will be weight loss in the product. The product will lose its weight. Subsequently, results in the deterioration of the quality. Why the cold chain is required? That is for the preservation of food, to reduce the wastages. Let me write it here. Need for cold chain. So to maintain the quality of product, to maintain the quality of product, to reduce wastage, to preserve the product, once the wastage is reduced, the food is preserved, there will be the wastage, the cost due to wastage is also reduced. Extend the shelf life of the product. So that's what I have discussed. Reduce wastage, extend shelf life and quality of product. Economic benefits in agriculture, pharmaceutical and food processing sectors. Suppose if for a particular product, if the demand is less at a particular time, the farmers, what they can do is they can store it, especially in case of products which is stored for a longer time, for a long duration, 6 months to 1 year or even more than 1 year. When the market price is dull or it is not as good as it was expected, or if the sales of the product sales is not as expected, so the preservation will help the farmer to sell the product when the market situation has improved, So next one is just in time. It is an approach to deliver, as the name indicates, just in time, to deliver the products on time. How this is possible is, like in this concept, the just in time, normally the raw materials are not stored or are not stored in the godown or in a place where the storage is there, raw material storage are there. So once there is a good relationship between the customer and the vendor, what happens? The raw materials, like it reaches from the vendor reaches the customer for further processing, for converting it into product, and simultaneously the product is sold in the market. So it's an approach to deliver the products on time. It aligns with the raw material from the supplier with the product delivery. It reduces the inventory cost because there is no requirement of storage of raw materials for for a longer time or even for a moderate period. So this advantages is better financial management, increased flexibility, enhanced product quality, optimize the process. This also eliminates the wastage of the raw materials. Suppose if the raw materials, the date of usage of the raw material has expired, has crossed its usage period. So then the entire raw materials have to be thrown out. It cannot be used for making quality product. In just in time, the relationship between the customer and the vendor or the manufacturer and the vendor should be a very healthy one. Temperature limits, when it comes to temperature limits, there are 3 or 4 types. See, for example, medicines and vaccines, some of them require a positive temperature, that is in the range from 2 to 8 degrees centigrade. Fruits and vegetables normally 2 to 5. So while I was explaining the cold storage, the design requirements, the positive temperature applications like horticulture product, floriculture, fruits, vegetables, mostly these items are stored between the temperature 2 degree and 5 degrees centigrade. Frozen items minus 15 to minus 20, all these temperatures are in degree centigrade. Frozen is from minus 15 to minus 20. Deep frozen, that is much lower than the frozen temperature, minus 25 to minus 30. So a comparison of the temperature limits in various locations, various countries. So in the first column, the various conditions like frozen, refrigerator or cold, cool, room temperature, etc. The values that is the standard values that is set by WHO, World Health Organization, Europe. What is the trend that is followed in Europe, USA and Australia? So if you take the frozen one, the recommended one as per WHO is minus 20. So in Europe, the temperature is for the frozen is around minus 15. Australia, it is close to minus 20, that is minus 18 to be more specific. In some of the, wherever the data is not very much authentic, so that is not mentioned from the source from where I have taken this one. Then for the refrigeration, this one 2 to 8 degrees centigrade, and in Australia 0 to 4. Cold 2 to 8 degrees centigrade. In Europe, it is 8 to 15. The recommended by WHO is 2 to 8. USA is minus 8. And Australia is 2 to 8. If you see the room temperature, the approximate room temperature, that is the suggested one is 15 to 25 as per the World Health Organization. And in Europe, it is almost matching with the one which is suggested by WHO. Next, a comparison between chilling and freezing process. Chilling process refers to a process which takes place in the positive temperature range, that is above 0 degrees centigrade, greater than 0 degrees centigrade, whereas freezing is less than 0 degrees centigrade, that is negative temperature. In case of chilling, the storage is on a shorter term, it's about 1 to 2 weeks, whereas frozen products are stored for longer term, 6 months or even more than 6 months up to 1 year. In case of chilling, the refrigerator is used. For freezing, freezers are used. In one of the earlier lectures, we have seen blast type of freezers, plate type of freezers, etc. Ice formation, there is no chance of formation of ice in chilling process, since the process takes place above 0 degrees centigrade, whereas in case of freezing, ice crystals are formed. Examples for chilling, this one, fruits and vegetables. Freezing is meat, fish and chicken, etc. Next, the concept of chilling injury. What do you mean by chilling injury? It is a damage. It is a physiological damage which is which occurs in fruits and vegetables due to exposure to non-freezing temperatures. Non-freezing temperatures. So when a product is exposed to a temperature other than the recommended temperature, especially if the temperature to which the product is exposed is less, then this type of injury occurs in fruits and vegetables. For example, if a product is supposed to be stored at, say, the recommended temperature is 4 to 5 degrees centigrade, and if it is exposed to a lower temperature than which is less than the recommended temperature, then chances of chilling injury will occur. It occurs when the product is exposed to lower temperature. It occurs at temperature typically in the range 0 to 15. 0 to 15. Examples are internal browning in apples. Sometimes we see there's a color change in the bananas, in other fruits also. There is the dull color in bananas. So this picture gives idea how the chilling injury occurs in banana. So here if you see, this is about 20 degrees centigrade. 20 degree centigrade. So when it is at 15 degrees centigrade, this is 15 degrees centigrade. This is 10 degrees centigrade. Maybe the letters may not be clear. Let me write it. This is 20 degrees centigrade, 15 degrees centigrade, 10 degrees centigrade, 5 degrees centigrade, 0 degree. Generally, at our homes, we don't use refrigerator to store the bananas. Bananas are normally kept at the whatever the temperature that is prevailing, ambient temperature that is prevailing on that particular day. So we can see as the temperature changes by 5 degree from 20 to 0, 20 to 0. So we can see the color changes, the dull color or the Brownian effect, especially in case of apples, the Brownian effect, Brownian internal browning, that is called internal browning in apples. Continuing with the chilling injury, chemical treatment. Certain chemicals can help to protect against chilling injury. Suppose when we have a controlled atmosphere storage, modifying the atmosphere surrounding the produce can reduce the injury. Genetic manipulation, developing chilling tolerant cultivars can also mitigate the problem, can solve the chilling injury. Preconditioning, exposing the plants to a short period of warmer temperature before chilling. Exposing the plants to a short period of warmer temperature before chilling can help them to adapt to lower temperatures. Intermittent warming, increasing the storage temperature during chilling can reduce the. So ultimately, if you see the solutions to solve this chilling injury, this occurs when the temperature of the product which is exposed goes below the recommended condition. So some of the solutions that are suggested in this slide, in the previous and this slide, is to slightly expose the product to a warmer temperature or slightly higher temperature before it is. Next one is cook chill system. It is a food preparation system where food is fully cooked, as the name indicates. Cook chill system. Cook chill system. It is fully cooked and chilled using a blast chiller, where the temperature of the controlled environment maintained is less than 5 degree, sometimes 2 to 4 degree centigrade. So it can be used. So the food item is completely cooked, then it is chilled using a blast freezer where the temperature is maintained, where the temperature will be maintained and stored at a controlled environment, for its use at the later period. The advantage of this type of system is the bacteria growth is minimized. It minimizes the risk of bacterial growth, reduces wastage. Once the bacteria growth is not there, the food wastage is reduced, cost is reduced, and it is one of the efficient and effective, cost effective method. Examples are soap, sauce, salad, etc. So in layman's term, this is cook chill system. Is the product is cooked and after which it is chilled with the help of a blast freezer and stored in a controlled environment. Next one is cold shortening. So this is process which takes place with meat, in meat. So it's a phenomenon in meat processing where muscles rapidly contract due to low temperature leading to tougher meat. It is a phenomenon in meat processing. It occurs when the meat is chilled quickly after slaughter before the glycogen in the muscle has been fully converted to lactic acid, causing a rapid pH decrease. With the pH in the range from 6 point, generally if it is between 6.5 to 7.5, we call it as neutral. If it is less than 6.5, less than the neutral value, it becomes the acidic, and if it is more, it becomes the alkaline. This rapid cooling, especially below 15 degrees centigrade, can cause muscle fibers to shorten, resulting in a denser, less tender texture. So why all these things are happening? In case when a proper method is not followed for whether it comes to food processing or food preservation, then damages or injuries are caused to such products. How to mitigate the cold shortening? Controlled chilling. Controlled chilling, as the name indicates, it is reducing the temperature to prevent rapid cooling. Physical restraint, preventing the muscle contraction by using physical means. Electrical stimulation, applying electrical stimulation to the carcass can help delay rigor and prevent shortening. Product process package. So it is a fundamental principle for ensuring the quality and safety of temperature sensitive product like food and pharmaceutical throughout their life cycle. Product process package. So it's like from the form the product is available for supply for sales in the market, before that one, how it is processed, how it is converted into product, then packaging before it reaches the end user. So in short form, it is called PPP, product process package. It considers the product itself, the processing methods used, and the packaging material. There are three things are involved. One is product. First one is product. Second one is process. And third one is packaging. It is critical aspect of cold chain management, ensuring the product temperature is maintained at every stage to preserve its quality and safety. Because the packaging material, the gases which are present inside the packaging material at the time of packaging the product plays a major role in maintaining the quality of the product. So product, raw materials, ingredients, process, when it comes to process, chilling, freezing. Chilling is above the positive temperature process, that is above 0 degrees centigrade. Freezing is below 0 degrees centigrade. Heating and pasteurization. This is done, pasteurization process is mainly used in dairy industries. Packaging, physical and chemical packaging, the properties of the packaging materials, packaging techniques, etc. So I will stop this lecture number 27, part 1. Thank you.